Newton's rings teach us a lot, especially now. The first time I heard about Newton's rings when I was in high school and my physics teacher demonstrated this experiment. A lens, flat on one side and convex on the other, is laid down on a horizontal metallic mirror with its convex side down. When monochromatic light is shined from above this lens, we will see an interference pattern, black spot at the center, then interchanging bright and dark circles around. My school teacher's explanation was, light is an electromagnetic wave, and it is partially reflected back from the convex surface of the lens, and the rest of it reflects from the mirror, and these two reflected waves either cancel each other, due to the difference in waves phases caused by the gap between the lens and the mirror, or they reinforce each other, where phases are almost the same. I asked my teacher, why is the center of the corona black? Shouldn't it be the brightest spot because at the center, where the lens touches the mirror, the gap between the reflecting surfaces is close to zero. So, the phase of the light when it reaches the convex lens surface is almost the same as when it reaches the surface of the mirror, right? Newton's rings image was exactly opposite to my teacher explanation, which would have led to a bright in its center corona. Neither my teacher nor the school book had an answer, and there was no internet back then. I got an explanation from a university physics professor a month later. When light reflects from an optically thinner medium, in this case, light is reflected from an air bordered with the convex side of the lens, the phase of the light does not change. When light reflects from an optically denser medium, in this case, light is reflected from the metallic mirror bordered with an air, the wave changes to the opposite, meaning phase shifts half wavelength. Thus, reflected waves cancel each other when there is almost no gap between lens and mirror, their phases become opposite. Some lessons from this story. Lesson 1. If you don't have a critical mind, you not only miss something important, but even if someone points you to it, you will accept any wrong explanation, like the rest of my class did. Lesson 2. Not understanding the matter of the subject does not prevent you from teaching or lecturing others, like my school teacher did. Next simple lesson can be learned from the origin/history of this discovery. Such rings interference pattern was discovered by Robert Hooke and published in 1665 in his popular book Micrographia, of which Newton had an annotated copy. But why then Newton's and not Hooke's rings? Sources say that Newton was impressed by Hooke's work, and he studied light properties himself, but only after Hooke's death Newton published his research on this subject. But here is another strike. Newton favored a corpuscular nature of light, and Hooke favored a wave-like nature of light, and Hooke's point was more appropriate within that experiment's context, though, according to Richard Feynman, it is impossible to explain in a classical way, as it is quantum mechanics in its heart. Attributing this discovery to Newton and not to Hooke teaches us. Lesson 3. Authority and supremacy play a significant role in both physics and history. Another well-known light interference experiment is double-slit experiment. Although double-slit experiment is 200-year-old, its major conceptual misinterpretations are less than a century old. Let's start from observation destroys interference pattern, observation impacts quantum world. Monochrome light coming through two slits creates an interference pattern on the screen behind. Double-slit interference.png. n.wikipedia.org. n.wikipedia.org. But when a detector is set before or after one or both slots to identify which way light, photon or a particle, goes through, no interference pattern is observed, only two bright stripes on the screen against the slits. What we learned about Newton's rings can explain interference pattern destruction even before diving into quantum mechanical concepts like wave function collapse. In Newton's rings and double-slit experiments monochromatic light is used and interference pattern is observed. That hints at a phase-like explanation. Any measurement device measures by probing a particle or a wave, while it passes through, and by doing that, it distorts the phase of the wave where it is measured, and the wave becomes out of sync, random, in comparison to the other part of the wave, which comes through another slit. Because of that measurement/disturbance, pattern disappears, and the image on the screen looks like if it is produced by two not correlated sources. So far, nobody has invented a non-disturbing/non-interacting measuring device. Detectors are electromagnetic in nature, and light is electromagnetic as well. Lesson learned. Lesson 4. Observation/probing distorts an experiment. Physicists worked even further around detection/measurements for the double-slit experiment. The most stunning was the so-called quantum eraser setup/observation/claim about future rewriting/influencing past. Please watch, which teaches us next lesson. Lesson 5. Some scientists will omit detail or two and ignore empirical evidence contradicting their theory/speculation/project/funding. Such ignorance, or even deception sometimes, might work for a while, as we learned in Lessons 13. Kudos to Sabine Hossenfelder for calling this misinterpretation out. I wonder how such callouts are met by the mainstream. Last but not least, the 2022 Nobel Prize for Physics about entangled particles measurements led to another extraordinary claim: universe is not locally real. Check Gambling and Nobel Prize for Physics, where locality of time disproves this unrealistic claim. Next lesson comes from that and many other Nobel Prizes. Lesson 6. Nobel Prize award does not make the research valuable and the scientists right. It is just a top of the mainstream tribute. It is chapter 33 and time matters, and there are more.